my video lecture. I am Dr. A.VELMURUGAN, Assistant Professor, Department of Mechanical Engineering, Government College of Engineering, Chettikari, Dharmaburi. From this video lecture, Thermal Engineering 2, Unit 5, Refrigeration and Air Conditioning System. Previously, we have discussed about the introduction of refrigeration system, vapor compression refrigeration system, vapor absorption refrigeration system, air conditioning system, and from module 6, we have discussed about the cooling load calculation and cooling towers. From this slide, from the figure, we have to clearly shown about the cooling load, how to from the hot condition and cold condition, the temperature will be, we should find out the temperature from that hot condition and also cold condition. From that cooling load, we should find out the load profile over a day. From the peak load condition, the basis of equipment and sizing, and also from the operation of energy analysis, and also we should find out the construction cost for the heating and ventilation and air conditioning system. What is the purpose of to take load estimate means it is the thermal energy that must be removed from the space in order to maintain the desired comfort condition. From that, the heating and ventilation and air conditioning system are used to maintain the thermal condition for comfort range. From that concept of room sensible heat factor and gas sensible heat factor and effective sensible heat factor RSHF and GSHF and ESHF and the effective sensible heat factor. From that, first we have discussed about the sensible heat factor is denoted for the SHF. It is the ratio between sensible heat and total heat is known as sensible heat factor. From mathematically, sensible heat factor is equal to sensible heat by sensible heat plus latent heat. Finally, we get the sensible heat by total heat. That is a sensible heat plus latent heat is a, we get the total heat. Next slide, we have discussed about the room sensible heat factor. The ratio between room sensible heat and room total heat is known as a room sensible heat factor. From that, mathematically we should find out the room sensible heat factor is RSHF. It is divided into, that is RSHF by RSHF plus RLH. We get the RS room sensible heat factor by room total heat. From that, room total heat is denoted for room sensible heat plus room latent heat. Next slide, we have discussed about the grand sensible heat factor. The ratio between the total sensible heat to grand total heat with the cooling coil is required to handle for the grand sensible heat factor. From the grand sensible heat factor is denoted for GSHF. We get total sensible heat factor by total sensible heat plus total latent heat. First, we should find out the total sensible heat means with the help of room sensible heat plus OASHF. The OASHF is the outside air from the sensible heat. From the TLH is denoted for RLH plus OALH. That OALH is denoted for outside air latent heat. We should find out the grand sensible heat factor means the ratio between total sensible heat to grand total heat with the cooling coil required to handle. Next slide, we have discussed about the effective room sensible heat factor. But ratio between the effective room sensible heat factor, heat to effective room and total heat. Effective room sensible heat factor is denoted for ESHF. It is equal to ESH by ESH plus ELH. From ESH is the effective sensible heater plus ELH means effective latent heat. So what is the purpose of you should find out the from the problem point of view from that fifth unit from the refrigeration and air conditioning system. If you find out the cooling load calculation for the large shopping mall, large cinema theater or large shopping mall or otherwise using for very large buildings, we have to using for that we need cooling load. So that condition you should apply these parameters to find out the first of all from the capacity of the room, and also we should how much we record for the temperature to operating, we get the cooling effect from the particular room. So that condition we have to using this concept of room sensible heat factor, grand sensible heat factor and effective sensible heat factor. From that cooling load calculation, we have to denote it for already I told about you should find out the room load and the total load. From the room load means which fall on room directly. From the total load means which fall on the air conditioning apparatus. From the room load, we should denote it for the room sensible heat, solar and transmission heat gained through the wall, roof and glass, etc. From the radiation of the transmission from the wall, roof and glass, etc. After that, infiltration, if you have any air medium or water medium, is infiltration from that room. Internal heat gain from the principle of power lights and appliances, etc. Supply duct heat gain, supply duct leakages, loss, fan horsepower. Next condition is room load. Room latent heat is infiltration, internal heat gain from people, power lights and appliances, etc. Vapor transmission, supply duct leakages, losses. Next slide, we have discussed about the total load. That is, the first one is a sensible heat, second one is a latent heat. From the sensible heat, the effective room sensible heat, return duct heat gain, return duct leakages, we find out the total sensible heat is TSH 1 and 2. From the latent heat, we find out the effective room latent heat and return duct leakages. From the total heat latent heat, we should find out the 1 and 2. If we find out the grand total heat, means that is a TSH plus TLH. From that, next slide, very important, that is a cooling tower. From the cooling tower is very essential for this thermal power plant and gas power plant and power generation sector. We need cooling tower is very necessary, because of that is from the thermal power plant we have to operating that turbine and boiler is from that high power generation. So that time we should produce the steam is more steam. So that condition, after usage of that turbine, that the excess steam is goes to the condenser and recirculated to feed water. And also there is more number of steam is used with the help of that cooling tower to cool the steam. So that condition we have to using this cooling tower is very essential for all the applications from that. Next slide, we have discussed about the introduction about the cooling tower. These are all the components used for the cooling tower: frame and casing, that is a support for exterior enclosure, and facilitate the heat transfer by maximum water and air contact. We have to using for the nozzle is the splash fill and the flame fill. Cold water basin receives water at the bottom of the tower. Drift eliminators capture the droplet in air stream and the air inlet from the entry point of the air. Lowers that equalize the airflow into the fill and retain the water within the tower. And also using the nozzle to spray the water to wet the fill, and using the fan high speed fan to deliver the airflow in the tower. Immediately we have to cooling the water. The cooling tower is used for two conditions. One is a natural draft cooling tower, another one is a forced draft cooling tower. From the natural draft cooling tower, that hot air is moves through the tower. The fresh cool air is drawn into the tower from the bottom of this tower. There is no fan is required because of the concrete is greater than 200 meters, less than 200 meter. Usually a large heat duties. This type of cooling tower is used for the natural draft cooling towers. Next tower is a natural cooling tower. From that natural cooling tower, the air flow is happen on this crash flow direction. From here, air drawn is crossing falling the water. Fill located outside the tower. From that air flow is because of from the shape of this cooling tower is we have to using that cold water from the collecting from the basin. This type of cooling water is used for in the thermal power station, because of we should produce the large power sector. We have to using this type of cooling towers. This one is a natural draft cooling towers. From that with the help of that air we have to cool the steam. Next slide, we have to see about the two types of flow. One is a crash flow, another one is a counter flow. From that counter flow, the air is drawn up through the falling of the water, filled located inside the tower. From this tower is used also. There is a two types of flow. One is a crash flow and a counter flow. With the help of this flow to control with the help of the air to cool the steam and used for the useful application. Next, we have to discuss about the mechanical draft cooling towers. From the mechanical draft cooling towers, we record the large fan to force air through the circulated water. Water falls over the fill surface. From here, maximum heat transfer. The cooling rates depend on the many parameters. Large range capacities can be grouped. Example, 8 cell tower. There, from the mechanical draft cooling tower, there are three types. One is a forced draft. Second one is a induced draft gas flow. Third one is a induced draft counter flow. From that mechanical draft cooling tower, with the help of that centrifugal fan, we have to reduce that hot water from here with the help of the nozzle spray from the from that filling application. We have to reduce the temperature from that steam. We get the cold water from here. We have to force draft cooling tower. From here, air is blown to the tower from the with the help of the centrifugal fan at the air inlet. The advantages of this cooling tower is it is suitable for the high air resistant, and the fans are relatively quiet. The disadvantage of this cooling tower is recirculation due to high entry and low air exit from the velocity conditions. Next one is a induced draft cooling tower. From the induced draft cooling tower is two types. One is a crash flow, another one is a counter flow. From the advantage of this cooling tower, less recirculation than forced draft towers, and also the disadvantages from this cooling tower is fan and motor drive mechanism is required for this mechanic from the induced draft cooling towers. From this figure, we have seen about the induced draft counterflow and induced draft counterflow tower with fill. From here, the induced draft cooling tower, the hot water is entered at the top, air enters at the bottom and exit to the top. Uses the force and induced draft fan. We have to cool this water with the help of this induced draft cooling tower counterflow and induced draft counterflow